starting with part B of module 2, where we'll be studying about the microwave passive devices. I mean to say the devices, the passive devices which will be making use in a microwave network. So first of all, before that, we need to know what are the passive devices. But let me just brief you out what are the contents that you are going to study in this module 2, part B of module 2. You'll be studying about coaxial cables, the types of coaxial cables, what is a connector and an adapter, and what are the types of connectors and adapters. Next, we'll be studying about the microwave attenuator and the different types of microwave attenuator. And next, you have the microwave phase shifter, which is also one of the passive device. And next, the microwave bends, twists, and corners, the varieties, diagonal couplers, and isolators. So all these are the one which comes under the category of microwave passive devices, which are connected in microwave applications. Just a minute. So starting with what do you mean by passive device or is microwave passive device? A device which is used in microwave network and which gives the performance as a passive device are called as passive devices. So you people know about the active devices and passive devices, which are uh, explained in the previous semesters. That is the power source, the power supply connections, whatever we need, the signal generator, the CRO, all those are active devices because depending upon the changes in the input parameters, the output parameters will vary. So whenever we change some parameter in active device, the passive device will have to adapt for it, and yeah, it has to give its performance in that particular manner. Like if I want to list the active devices in your low frequency networks are the power supplies, the signal generator, and the CRO. And the passive devices, for example, are the resistor, the capacitor, the inductors. Okay, so all those I can call it as passive devices. And you know what is the function of a resistor, capacitor, and inductor. In the same way, here also in a micro network, the devices which changes its performance in accordance to input given, they are called as the passive devices. So the main important passive devices which we'll be using in most of the micro networks are a microwave attenuator, phase shifter, microwave bends, twists, and corners, the varieties, that is the E plane T, H plane T, magic T, and the Dashon couplers and the isolators. These are all the microwave passive devices which is are going to study in this chapter or is in this module. So let us come for the second one. Let us know what are the coaxial cables. Means the cables are the one which are used to connect one device with the other in a transmission line. If I want to take an example, the CRO probe, whatever you connect that wire, that black cable, whatever is there, that is what we call it as a coaxial cable. So you know that in a CRO probe which you connect, one end of the cable will be connected with an adapter which can be connected to a signal generator or else which can be connected to a CRO. And the other terminal will be having two output terminals, that is one is the positive and one is the negative, where one is the red line, one is the red point and other one is the black point, where red is for the positive term, red is for the positive and black is for the negative. Okay, so you should remember at least how you connect a CRO cable. From yours, this you will take a CRO cable which has one terminal, which has two terminals. That is, this will be a black type of cable, and there is a silver type of circular thing which is called as an adapter or a connector, and this connector will go to the socket of the CRO. Means whether you want to take the output of channel 1 or channel 2, the CRO, the connector will be connected to the CRO. And the other end of the coaxial cable, you can see that you have two clips, which is the banana clip, and one will be red in color and the other one will be black in color. So the black terminal is always connected to the ground in this of your circuit, and the red cable is connected to this point where exactly you want to take the output. Okay, so this what we call it as coaxial cables. The cables which are used to connect one device with the other in a transmission line are called as coaxial cables. Okay, so the black cable which you see in your CRO Pro, they are called as coaxial cables. And one more example is the patch cords which you connect in your DE lab. The patch cords are device where it would be red or black, and at the end you have a socket, you have a pin type of thing, pin type of terminal where the cable will have two terminals. One is to where it has to go to input and where it has to connect the output. Okay, so even the batch cards which you connect in your DE lab, that is DST lab, whatever you are conducted in your third semester, even those patch cards are also consist of the coaxial types of cables. Okay, so that is what we mean by a coaxial cable. And coming for the types of coaxial cables, there are three types of coaxial cables. It is flexible type of cable, the semi-rigid cable, and the rigid type of cable. Okay. So first of all, you came to know what is a coaxial cable. A coaxial cable is a cable. Cables are the cables which are used to connect one device with other in a transmission line. And coming for the types of cables, we have three types of cables. That is flexible cable, semi-rigid cable, and rigid type of cable. So what does this mean? By the name itself, you can understand a flexible cable is a cable which has some flexibility, means at least in terms of the rotation. Okay, so a flexible cable is a type of cable which has a flexibility so that it can be folded for a smaller diameter. And the second one is semi-rigid type of cable. The semi-rigid type of cable are the cables which are slightly harder than the flexible cables, but it cannot be folded to the smaller diameter as we can do it for a flexible cable. And the third one is rigid type of cable. The rigid type of cables are the cables which are very hard and which cannot not be folded for a smaller diameter at all. That's why the name is given as rigid. Means it is very tight. Okay. So the types of coaxial cables are flexible cable, semi-rigid cable, and the rigid type of cable. So let us know what are the internal structures of the cables of these cables. So the first one is flexible type of cable. This is the diagram of the flexible cable, where the flexible cable consists of four layers. One is the multi-strand center conductor, which is basically a conductor and else in the conductivity. And above that is a layer which is called as polyethylene, which is the dielectric core material. And this is foam polyethylene, which acts as the dielectric core material in between the outer conductor and the interconductor. And after that we have single or double braided outer conductor, and finally we have the fourth layer, which is the insulating dielectric jacket. Because whenever we hold conductors in hand, there are chances of electrical shock where this shocks has to be avoided. So what we do is we cover the cable with a insulating jacket, which acts as a insulation. Like how when you want to stop the propagation of the signal or something, you insulate, uh, you just hold that, you just wind that cable with the insulating tape. In same way, here, to avoid shorts, to avoid the electric shocks for the people who are handles this cable, an insulating jacket, which is a dielectric jacket, will be mounted on the last layer. It's very much similar as your CRO Pro. Okay, just please remind that. So here, a flexible type of cable is a cable which consists of four different layers. One is the center conductor, that is, which is the inner conductor. So just when you open a cable, if you open the CRO cable itself, you can see all this inside. Okay, there will be a conductor which is a copper material, and above the copper conductor layer, there will be a dielectric core material. And here, in a flexible type of cable, the type of dielectric core which we are using is foam polyethylene, FOAM, foam polyethylene. So this foam polyethylene is a material which gives the property of flexibility. And above this dielectric material, we have the single or double braided outer conductor. So depending upon the thickness of the conductor, we will decide whether the conductor is single braided or double braided. Now, single braided means a single layer of mesh, double braided means double layer of mesh. And finally, we find the insulating dielectric jacket. Okay. So this is about flexible type of cable, and the resistance of this flexible type of cables are 50 ohms or it will be 75 ohms. So the main important thing why it is called as a flexible cable or is why this allows the property of flexibility is due to the presence of the dielectric material, which is foam polyethylene. Coming for the second type of cable, that is the semi-rigid type of cable. Is semi-rigid type of cable is the cable which is either not too flexible or else which is not too hard to be folded for a smaller diameter. It almost gives the same properties and the performance as the flexible cable or the rigid type of cable. So, a semi-rigid type of cable also is a cable which consists of the inner conductor and the outer conductor. And in center, at the center, that is in between the inner conductor, this is the inner conductor and this is the outer conductor. So in between this inner conductor and outer conductor, the space which is in between, it is filled by a dielectric material. And this dielectric material is the one which gives the property of rigidity. Rigidity means say that the tightness of the uh, device or as the tightness of the cable is exhibited by means of the dielectric material which we make use. Okay, so this is the semi-rigid type of cable where it consists of the inner conductor. This is the inner conductor because as you know, the copper pipes which are you see in any connectivity, normally it will be thin. That's why the diameter of this inner conductor is also thin. And after that, the dielectric material is filled in between the inner conductor and the outer conductor. After filling the dielectric material, then finally we have the outer conductor. And above the outer conductor, finally we'll have the insulating jacket. Okay. So here in the semi-rigid type of cable, we just normally make use of a dielectric material to get the property of semi-rigidity. Next one is the third type of cable, coaxial cable, is the rigid type of cable. The rigid type of cable is a cable which is very hard to wind up, fold for a smaller diameter. Means you would have seen few of the you would have seen the wires, which is optic fiber cables, which will be mounted onto the drums, which were used for transmission lines. That is the telephone lines. Okay, you would have seen the huge drums, which is mounted here and there on the side of the road, where though they are called as optic fiber cables. It consists of about 15 to 16 cables inside that insulating jacket. Okay, so those type of cables are used for transmission of signals in for telephones, for telephone signals. That is BESCOM. So those type of cables are what we call as rigid type of cable. Means it's very difficult for to fold the rigid type of cable for a small diameter. Suppose if you take an example, if you just when you are handling the patch cards or as the CRO probes in your lab, if you just want to fold it around your finger, you can easily fold it. But in the same way, suppose if you want to take a cable wire connected, means for your televisions, whenever you call a person for cable connectivity, he will give you the box, the setup box, and also a cable terminal which should be adapted for the cable, which should be adapted for the cable setup box, right? So that cable, if you see, if you just want to fold that, it appears rigid. Means you cannot fold it very easily. And when you open the cable internally, you can see that is it would be normally double braided. It has a plastic cap inside, and externally it is covered by a rubber. This is the rigid type of diagram of a rigid type of cable. So as I cable is a cable difficult to which will be difficult to fold the cable for a smaller diameter. And here the rigidity is obtained by means of the dielectric material. The dielectric material which we are using in this rigid type of cables is air. Okay. So what we do during manufacture of rigid type of cables are, this is the cable which you see, and inside the cable, whenever they manufacture, this is the internal conductor, inner conductor, and this is the outer conductor. And inside the diametric surface, we connect we install the dielectric spacers. These are all what we call it as dielectric spacer. The circular type of device is there, right? The circular one. These are what we call it as dielectric spacers. So this is the inner conductor where the signal has to propagate. This is the path where the signal has to propagate. And in between this and this, these are what we call it as dielectric spaces. And in between these dielectric spaces, the dielectric medium, which is the air, it is connected. The dielectric material, which is air, is normally filled so that the tightening of the spaces will be there. So whenever air is filled, as it has more capacity, the cables becomes rigid. Okay, so a rigid type of cable consists of the inner conductor and the outer conductor, and inside the cable there are dielectric spaces which are placed at equal distance, and the gap between these dielectric spaces are filled with air, and whenever it is filled with air, it gives the property of rigidity. That's why it is difficult to fold the rigid type of cable for a smaller diameter. The one example which you can see is the optic fiber cables which is mounted on drums. Few of you would have observed, at least during your school days you would have observed, not nowadays, because nowadays the technology has changed. For telephone connections and all, we are just making use of a very simple flexible type of cable. The buried underground buried type of cables nowadays it's less, it's very less. Okay, because as it was huge and the complexity of maintenance was high, nowadays they have started with a trend where they are connecting the flexible type of cables which are just overlaid from across in the layer itself, means one building to other building, like how they give the cable connection wise, right? And the act fiber net cables. In the same way, nowadays the telephone lines are also conducted using the same technology. So, rigid type of cable, it is difficult to manufacture, which has cost is high, and which is difficult to maintain, and it is also difficult for making it portable from one place to other place, transfer it from one place to other place. Okay, so that's why we don't use the rigid type of cable for most of the applications, but instead most of the applications we make use of flexible type of cable or as the semi-rigid type of cables.